Yes, there are requirements for using ring-type connectors on current transformer connections to a terminal strip. Firstly, proper sizing is critical. Ring-type connectors should be sized to match the wire gauge of the current transformer leads and the diameter of the terminal screw. Secondly, the ring connectors should be made of the same material as the screw and busbar to avoid galvanic corrosion. Thirdly, proper installation is important. The ring connector should be fully screwed onto the current transformer leads and securely fastened to the terminal strip. Fourthly, double ring lugs, or U-connectors, should be used when connecting multiple current transformer leads to a single terminal. Fifthly, ring connectors should be crimped onto the current transformer leads using a suitable crimping tool. Sixthly, insulation is important. Ring connectors should be insulated or have an insulated barrier to prevent short circuits between adjacent terminals. Consider torque as well. Follow the manufacturer's recommended torque specifications for tightening the terminal screws. Tightness is also important. Ring connectors should be tightened sufficiently to ensure a good electrical connection, but not over-tightened as this can damage the terminals. Regularly inspect the ring-type connectors for any signs of corrosion, looseness, or damage. Failure to follow these requirements can result in poor electrical connections, overheating, and potential current transformer failure. Sizing is paramount. The ring connector must accommodate the conductor size and the terminal strip screw size. If the ring connector is too small for the conductor, it won't properly crimp, leading to a loose connection and potential arcing. If it's too large for the terminal screw, it won't provide adequate contact pressure. Material compatibility prevents corrosion. Dissimilar metals in contact can create a galvanic cell, leading to corrosion. For example, using a copper ring connector on an aluminum busbar can cause the aluminum to corrode over time, weakening the connection. Using the same material for both the connector and the terminal minimizes this risk. Secure installation is key for a reliable connection. A loose connection increases resistance, generating heat and potentially causing a fire. Fully screwing the ring connector onto the current transformer lead ensures a good mechanical and electrical bond. Securely fastening it to the terminal strip maintains that bond over time. When multiple current transformer leads need to be connected to a single terminal, double ring lugs or U-connectors provide a secure and organized way to do so. This prevents the leads from overlapping or coming loose. Crimping is essential for a gas-tight connection. A proper crimp creates a cold welt between the conductor and the ring connector, excluding air and moisture. This prevents corrosion and maintains a low-resistance connection. Using the correct crimping tool for the connector size and type ensures a proper crimp. Insulation prevents short circuits. In a terminal strip, terminals are often closely spaced. Insulated ring connectors or barriers prevent accidental contact between adjacent terminals, which could cause a short circuit. Torque specifications provide the correct tightening force. Too little torque can result in a loose connection, while too much torque can damage the terminal or strip the threads. The manufacturer's specifications ensure the correct balance between these two extremes. Regular inspections identify potential problems early. Corrosion, looseness, or damage can all compromise the connection. Regular inspections allow you to address these issues before they lead to a failure. Using appropriately sized ring connectors ensures a secure mechanical and electrical connection. The connector's inner diameter should match the conductor's outer diameter for a proper crimp. The connector's hole size should match the terminal screw size for a secure fit on the terminal strip. Material matching between the ring connector, terminal screw, and busbar minimizes the risk of galvanic corrosion. Galvanic corrosion occurs when similar metals are in contact in the presence of an electrolyte, such as moisture. The more noble metal corrodes, the less noble metal. Choosing the same material for all components prevents this. Correct installation involves several steps. Firstly, strip the current transformer lead to the correct length. Secondly, slide the ring connector onto the stripped wire. Thirdly, crimp the ring connector using the appropriate tool. Fourthly, place the ring connector on the terminal strip screw. Fifthly, tighten the screw to the specified torque. Double ring lugs or U-connectors provide a secure way to connect multiple wires to a single terminal. This is often necessary when connecting multiple current transformer leads or when using a single terminal for both the current transformer lead and a grounding wire. Correct crimping is essential for a reliable connection. The crimp should be tight and uniform, creating a gas-tight seal between the connector and the wire. Use a crimping tool that is specifically designed for the type and size of ring connector being used. Insulation prevents short circuits and protects personnel from electrical shock. Ring connectors should be insulated or covered with an insulated barrier to prevent accidental contact with other conductors or grounded surfaces. Torque specifications ensure that the terminal screw is tightened to the correct tightness. Over-tightening can damage the terminal or strip the threads, while under-tightening can result in a loose connection. Use a torque wrench to tighten the terminal screw to the specified torque. Regular inspection should be performed at least annually or more frequently in harsh environments. Look for signs of corrosion, looseness, or damage. Replace any damaged or corroded ring connectors immediately. Considerations for selecting ring connectors include the wire gauge, terminal strip screw size, material compatibility, insulation requirements, and environmental conditions. Select a ring connector that is appropriate for the specific application. Proper crimping techniques are essential for creating a reliable connection. Firstly, select the correct crimping die for the size and type of ring connector being used. Secondly, insert the wire into the ring connector. Thirdly, place the ring connector and wire into the crimping tool. Fourthly, crimp the connector according to the tool manufacturer's instructions. Fifthly, inspect the crimp to ensure that it is tight and uniform. Additional torque considerations depend on the application and the terminal strip manufacturer's recommendations. Follow the manufacturer's recommendations for torque values. If no torque value is specified, use a general torque table for the screw size and material. Regular inspection procedures should include a visual inspection for corrosion, looseness, and damage. Also, check the tightness of the terminal screws using a torque wrench. If any problems are found, replace the ring connector or tighten the terminal screw as needed. The correct wire stripping length is critical for a proper crimp. Too little exposed wire will result in a weak connection, while too much exposed wire will create a potential safety hazard. The wire stripping length should be equal to the length of the ring connector barrel. Using the appropriate crimping tool is essential for a reliable connection. Different types of crimping tools are available for different types of ring connectors. Use a tool that is specifically designed for the type of ring connector being used. When selecting ring connector materials, consider the environmental conditions. In corrosive environments, use ring connectors made of corrosion-resistant materials such as stainless steel or tin-plated copper. Correct terminal strip screw tightening techniques are important for preventing damage to the terminal strip. Firstly, use a torque wrench to tighten the screws to the specified torque. Secondly, avoid over-tightening the screws. Thirdly, use a backup wrench to hold the terminal strip in place while tightening the screws. Considerations for using double ring lugs or U-connectors include the wire gauge, terminal strip screw size, and the number of wires being connected. Select a connector that is appropriate for the specific application. When insulating ring connectors, use heat shrink tubing or insulated boots. Heat shrink tubing provides a complete seal, while insulated boots provide easy access to the terminal for testing and maintenance. Proper documentation of ring connector installations is important for future maintenance and troubleshooting. Keep a record of the ring connector type, size, material, and location. Also, record the date of installation and the torque value used. Additional safety precautions should be taken when working with current transformers. Firstly, always de-energize the circuit before working on the current transformer. Secondly, use insulated tools. Thirdly, wear appropriate personal protective equipment, such as gloves and safety glasses. Remember to refer to relevant electrical codes and standards for specific requirements. The National Electrical Code, or NEC, provides guidance on the proper installation of electrical equipment, including current transformers and ring connectors. Understanding the function of a current transformer is vital for proper installation. A current transformer is used to measure alternating current. It produces a current in its secondary which is proportional to the current in its primary. Current transformers are used extensively for metering and protection in electrical power systems. The selection of the appropriate current transformer ratio is also a key element in ensuring accurate measurements. The current transformer ratio defines the relationship between the primary current and the secondary current. For example, a current transformer with a ratio of 100:5 will produce a secondary current of 5 amps when the primary current is 100 amps. It's important to verify that the current transformer's burden rating is adequate for the connected metering or relaying devices. The burden rating is the maximum volt amps the current transformer can supply at its rated secondary current without exceeding its accuracy class. Proper grounding of current transformer secondary circuits is essential for safety. Grounding the secondary circuit provides a path for fault current to flow in the event of an insulation failure, protecting personnel and equipment. Keep current transformer secondary circuit short and direct to minimize impedance. High impedance in the secondary circuit can reduce the accuracy of the current transformer. Using shielded cable for current transformer secondary circuits can help to reduce noise and interference. Shielded cable minimizes the impact of external electromagnetic fields on the signal. Regularly testing current transformers is a vital step to ensure they operate correctly. Testing can reveal issues such as insulation degradation, open circuits, or short circuits. Understanding the current transformer's accuracy class will also allow for accurate usage. The accuracy class defines the maximum error that the current transformer can introduce into the measurement. Calibration of current transformers is recommended to maintain their accuracy. Calibration involves comparing the current transformer's output to a known standard and adjusting it as needed. Installing surge protection devices on current transformer secondary circuits can protect them from transient overvoltages. Surge protection devices divert surge current away from the current transformer. Use caution when working with current transformer secondary circuits, as opening the secondary circuit while the primary is energized can create dangerously high voltages. Always short circuit the secondary before opening it. When multiple current transformers are used in parallel, they must be properly phased to ensure accurate measurements. Improper phasing can result in inaccurate readings. Regularly inspect current transformer connections for signs of corrosion or looseness. Corrosion or loose connections can increase resistance and reduce the accuracy of the current transformer. Using appropriate labels and markings on current transformer circuits can help to prevent errors. Labels and markings should clearly identify the circuit and its function. The importance of training personnel on the proper installation, operation, and maintenance of current transformers cannot be overstated. Proper training can help to prevent errors and ensure the safe and reliable operation of the equipment. When replacing current transformers, it's important to select a replacement that is compatible with the existing system. The replacement current transformer should have the same ratio, burden rating, and accuracy class as the original. Consider using split-core current transformers for applications where it is difficult to disconnect the primary conductor. Split-core current transformers can be installed without interrupting the power supply. Ensure the current transformer's polarity markings are properly observed during installation. Incorrect polarity can result in inaccurate measurements. Understanding the different types of current transformers available, such as window type, wound type, and bar type, can help to select the appropriate type for the application. The environmental conditions where the current transformer is installed should also be taken into account. Consider factors such as temperature, humidity, and exposure to corrosive substances. Using current transformers with built-in protection features, such as overcurrent protection or overvoltage protection, can help to improve system reliability. Keep current transformer enclosures clean and free from debris. Debris can interfere with the operation of the current transformer and reduce its lifespan. Regularly check the current transformer's insulation resistance to ensure it is within acceptable limits. Low insulation resistance can indicate insulation degradation and potential failure. Ensure the current transformer's nameplate information is readily accessible for reference. The nameplate provides important information about the current transformer's characteristics and ratings. Document all current transformer maintenance activities, including inspections, tests, and repairs. This documentation can be helpful for troubleshooting problems and tracking the performance of the equipment over time. Review and update current transformer procedures regularly to ensure they are consistent with best practices. Current transformer technology is continuously evolving, so it is important to stay up to date on the latest developments. When disposing of old current transformers, follow all applicable environmental regulations. Some current transformers may contain hazardous materials that require special handling. Using current transformers as part of a comprehensive energy management system can help to reduce energy consumption and costs. Current transformers can provide valuable data about energy usage, which can be used to optimize system performance. Ensure the current transformer mounting is secure and stable. Vibration or movement can damage the current transformer or its connections. Use appropriate conduit and fittings to protect current transformer wiring. Conduit and fittings can prevent damage to the wiring from physical hazards or environmental conditions. Regularly inspect current transformer grounding connections to ensure they are secure and effective. A poor grounding connection can create a safety hazard. Consider using current transformers with digital outputs for integration with automated systems. Digital outputs can provide real-time data about current flow, which can be used for monitoring and control. Ensure the current transformer's operating temperature is within its specified limits. Overheating can damage the current transformer or reduce its lifespan. Use appropriate cooling methods such as ventilation or forced air cooling if necessary. Regularly calibrate the current transformer's metering equipment to ensure accurate readings. Metering equipment can drift over time, so regular calibration is essential. Consider using current transformers with multiple secondary windings for flexibility. Multiple secondary windings can provide different current ratios or power different devices. Ensure the current transformer secondary windings are properly terminated. Unused secondary windings should be short-circuited to prevent damage. Using current transformers as part of a protective relaying system can help to protect equipment from damage due to faults. Protective relays can trip circuit breakers to isolate faulty equipment. Ensure the current transformer's burden rating is sufficient for the connected protective relays. An insufficient burden rating can prevent the protective relays from operating correctly. Regularly test the current transformer's protective relaying system to ensure it is functioning properly. Testing can reveal problems with the current transformer, protective relays, or circuit breakers. Consider using current transformers with built-in self-monitoring capabilities. Self-monitoring capabilities can provide early warnings of potential problems. Ensure the current transformer's self-monitoring system is properly configured and maintained. The self-monitoring system should be regularly tested to ensure it is functioning properly.